Welcome to anyone tuning in to video 1 of our Projectile Motions unit for IB Physics HL. In this video, we'll be going over 4 questions that help apply knowledge to IB exam-style questions. Now, let's get started with the first question. Question 1. A slingshot fires a rock horizontally off a cliff with an initial speed of 15 meters per second. If the cliff is 5 meters high, how far from the cliff did the rock land? This is a typical SUVAT question, where 3 of the 5 SUVAT variables are given to us through the question. The next step for us to take is to find out which other variable is required to solve the question. The question is asking us for the displacement of the rock, so we need to find velocity and time. And the velocity is already given to us, so we just need to find the time. However, the trick here is to use the vertical components of the question to find time, since we don't have enough information to directly find time based on the horizontal motion of the rock. Therefore, we'll use the equation s equals a over 2 times t squared to find time. With this equation, we can now find that time is around 1.0096 seconds, and the total distance the rock travels horizontally is 15.14 meters. Question 2. A baseball player throws a baseball to his teammate 40 meters away. If the ball was thrown and caught at the same height, what was the time taken for the baseball to reach his teammate? The initial speed of the baseball was around 35 meters per second and thrown at an angle of 25 degrees. This question requires us to first notice that the information given will not always directly link to the solution. Additionally, this is also a great example of projectile motion questions not always requiring SUVAT to solve. Here, the given vector is 35 meters per second at a 25-degree angle. We need to break this down into its horizontal and vertical components using trig equations. Then, since we know the distance traveled and the speed of the ball horizontally, we can find the time by using displacement over velocity. In this case, it's 1.261 seconds. Question 3. Make a velocity and acceleration version of the displacement time graph given below. Here, we have a displacement time graph that increases exponentially and decreases in a similar manner. From this, we can tell that there is a linear velocity increase and then a linear velocity decrease. Again, we can also tell that there is an constant acceleration and a constant deceleration. Question 4. A cannonball fires a ball at an initial speed of 30 meters per second with an angle of 24 degrees. Find the maximum range of the ball. Here, we'll be trying to find the time taken for the cannonball to hit the ground and use that time to multiply it with the speed and find the maximum distance. Here, we're not given the displacement, but we are given the initial speed, final speed, and acceleration. Using these three, we'll be trying to find time. The initial speed will be 30 sine 24, or 12.2, and the final speed will be 0. We'll have an acceleration of negative 9.81 due to gravity. Using the equation v equals u plus at, we can rearrange it into t equals v minus u over a. Hence, we get t equals negative 12.2 over negative 9.81, or 1.24. However, we must remember that this time, 1.24 seconds, only takes into account half the total travel time the cannonball takes. This is because the SUVAT equation we used only represents from the start of the cannonball being fired to its peak. Hence, we need to multiply the time by 2 and get t equals 2.48. Once we do so, we can just use displacement is equal to speed times time and get a total displacement of 68.2. Bob, who weighs 80 kilograms, rides a car that weighs 1 ton with a velocity of 32 meters per second. A car suddenly pulls out in front, and Bob tries to stop using his brakes. He stops 1.8 seconds later. Calculate the decelerating force. Just like any other SUVAT question, we're going to first write out all the variables that are known to us. First off, displacement is unknown, and the initial speed u is 32 meters per second. The velocity is 0 since we want to stop, and the acceleration is unknown. We also have the time, which is 1.8 seconds. Using this information, we'll be using v equals u plus at, and rearrange it into a equals v minus u over t to find the decelerating force. Once we do this, we get a is equal to negative 32 over 1.8, or negative 17.78. Since we're trying to find the decelerating force, we have to use the equation F equals ma. And we know that mass is 1 ton times 80 kilograms, making it 1,080, times the acceleration, which is negative 17.78. Hence, we get a total of negative 19,200. And there we have it, 4 exam-style questions on projectile motion. If you found this video helpful, please feel free to see some of our other content explaining IB math or physics through our channel. Thank you for watching, and we'll see you next time.